Welcome everybody to Kotlin Office Hours. I'm Russell, for those of you who haven't met me, and I'm just going to give a quick introduction to the meetup before we get into our talks. So here's a rough agenda. I don't even know if this is what we're going to stick to today because we're not in our usual location. But one thing I should point out is, as we do every month, we have a raffle for a JetBrains IDE license, which we haven't been pointing out to enough people tonight. So if you are interested in that, stick your name in the little Tupperware over here on the right. Random little household items. I don't know anything because I don't work here. There's bathrooms out the door. Women's room is on the left of the elevators and management is on the right. So just a couple things about the meetup. We meet typically on the second Thursday of every month. You might notice today is the third Thursday, but pay no mind to that. And we're a monthly meetup focused on Kotlin development, trying to aim at people of all backgrounds, not just Android, and we'll hear about some of those other backgrounds tonight. And we try to aim things both at new users of the language and at more experienced ones. We are always looking for speakers. So if you're interested in giving a talk at a future meetup, come say hi to me. You can also talk to my co-organizer, Anton, and our emails are on there if you want to shoot us a message. You can find us at various social media. Primarily, we're on Meetup. You can also find us in the on Twitter, Facebook, and in the Boston channel of the official Kotlin Slack. A couple notes about Intrepid. The organizational team of a meetup is all part of Intrepid, which is a division of Accenture. We do digital product design and development. We're pretty big into Kotlin these days. So if that sounds interesting to you, come talk to us. Also I'll leave a moment for Jay of Cantina to talk a little bit about our host tonight.
Thanks. Hey everybody, how's it going? Welcome to Cantina, thanks for coming. So Cantina, we're also a digital design development agency. We work with clients in all sorts of different industries, clients of all sorts of different sizes, startups all the way up to Fortune 1000 brands. Tons of different technologies, but Kotlin's a big one for us. And we're always looking to hire smart people. So if that sounds good to you, come give us a talk. All right, thanks.
And with that, some other coming attractions. We'll be back next month at our usual location at Intrepid in Kendall Square on February 14th. I didn't correctly update the slide. It will not be at Cantina Consulting. It will be at Intrepid. I always like to call out the informal Android meetup that the Boston Android GGG puts on that Beth hosts. It's a fun time to chat Android stuff if that's interesting to you. April 8th and 9th will be DroidCon Boston, so that's coming up. That's a big event. If you're interested in submitting a talk for that, the call for papers is open through January 31st. And if there's anything else fun going on, be sure to let me know and I can add it to this list. And with that, we can pass things on to our speakers, starting with Daniel Bostwick.
Thank you, Russell. Cool. Go. Sorry. Yeah. Yep. It's all me. See if I can remember my password. That would be a little bit monotonous. All right. Okay. And we're still recording. Good times. 1297. Slide captions. Got it. There we go. All right. Hey there. Welcome to Cantina. My name is Daniel Bostwick, and I'm going to be talking about Kotlin. Cool. Full stack Kotlin specifically. So actually, I wanted to ask you all a few questions first. Who here regularly uses Kotlin already, like as part of their daily job? Which is most people, except maybe Matthias. I know he's an iOS dev in the back. No. All right. Who here has ever suffered from long Gradle build times? That should be pretty much everybody use Kotlin. Yeah. Who here got into Kotlin because of Android? Okay. Who here has done full stack development? Who here has done full stack development in Kotlin? We got one hand. Okay. Nice. I want to talk to you afterwards. Not for money, though. Not for money. Yeah. Okay. And who here works in consulting versus a product company? All right. Good. Good. Perfect. All right. Cool. Because consultants, I've got a talk here, but what I really wanted to do actually was pitch you all on a startup for you all to build for me. Okay? Yeah. So the problem is cats are the most important thing ever created in the history of things that were created. And there's lots of places on the to get interesting facts about cats on the internet, but the problem is there's no central location. So obviously we need to build that, right? Cool. So our solution, cat facts, a single place for you to get information about cats. We've already validated the market here. You can see that people love cats, and it's definitely something that's a needed product. The market size is growing every day. And there's obviously a business model here too. So at some point, we'll profit. Amazing. And we've already lined up a great team to make this as well. But we need your help to figure out how to do this. So yes, this was a blatant way to get my animals into a talk. How would you build this digital product? Something like this is honestly pretty simple and something that we've done a lot. You might take a look at it and think to yourself, okay, I'm going to build myself an API-backed web and mobile application because it's a digital product and that's what we spend most of our time doing. And the technologies that you might reach for in order to solve this problem have definitely changed over time. 10 years ago, Ruby on Rails was kind of the cool hotness, unless you were somebody weird who used Groovy on Rails, but that's crazy. And we've moved on from that to various JavaScript frameworks. And even today, you might think to yourself, oh, whatever, I'll just throw a Realm database at it and be done. Let somebody else like Firebase do all my hard work for me. They've even got robots that'll write the app. They don't have that. But at this point, we're all Kotlin developers, and there's no reason that we shouldn't just use Kotlin for it. But in doing that, it brings up an interesting question. If we're writing a multi-system application where we've got a web API and we've got a mobile application and maybe we've got a web app or something, you know, we've got a lot of different code and we can't all store that in the same just single project. So we need some way to figure out how to organize and store all of our code so that, one, we don't have to write as much of it, and we can just reuse code where possible, and two, so we don't go insane from having our web code in our mobile code, or worse, database models living in an Android app, which is definitely something that I've seen and is not pretty. So that brings us to clean architecture, which who here knows Uncle Bob? Okay, yeah, he's a little bit of a controversial figure. We've studied him a little bit here at Cantina, and the general consensus seems to be that he knows what he's talking about, but sometimes he takes it a little bit too far. Anyways, I stole this image from his blog, and clean architecture is basically a way to solve that problem of organizing your code base. And for some people here who work on projects that I'm working on as well, this might also be a different talk called, Why Do We Have So Many Gradle Modules? And the reason is because of this slightly confusing and colorful image. So let's talk about clean architecture. First, disadvantages. You're going to write more code than if you were to just take a Realm database or a Firebase installation and just throw it at the problem. You're going to experience increased build time because you're going to end up with multiple Gradle modules. You're going to have an increased number of interfaces, which means that you have to be careful not to over-architect and get yourself into the hell that is multiple, that is some of the Spring interfaces. So that said, if we have all these disadvantages, why would we pay attention to that strange multicolored diagram? Separation of concerns. We've got all these different parts of our system. We want them to all talk to each other. And they all do different things. So we want each little part of our system doing its own little thing without regards for the rest of the system, so it can just concentrate on what it needs to do. Which there are a few more reasons, getting in a little bit deeper into it. You've got independent of frameworks, testable, independent of UI, independent of database, really independence here, which allows us to be more agile than just picking one solution or picking one technology and basing everything on it. And I used the word agile on purpose. I know it's a little bit of a loaded term, because everyone here is doing agile development and everyone's doing it a little bit differently. But when I said agile, the way that I meant it is in the ability to consistently move forward with your code and be able to respond to changing conditions over time, as well as clearly implement the scope of your application. It's a little bit long-winded, but it's an overloaded word. So we've got all of these advantages, and we've got an interesting diagram, but it all really boils down to this one rule. The whole multicolored diagram is basically formed on the dependency rule. We've got all these circles with little arrows pointing in, and the dependency rule says source code dependencies can only point inwards. Nothing in an inner circle can know anything about the outer circle. And this is actually great, and it brings us to unidirectional data flow, which is really powerful and helps us to better understand what our code is doing. But like some things, it's a little bit difficult to talk about in the abstract, like I've been doing for the last 5 minutes. So let's actually take a look at what something looks like this. So I want to look at cat facts. And we're going to ignore the terminal right here. And we're going to ignore this layout that I still have open. And this, got a whole bunch of stuff open. All right. And actually take a look at the project. So we've got a bunch of different modules here. And these different modules do different parts of the system. The most important part of the system is actually this one right here, the core module. So let's explore Cat Facts Core, which contains entities, services, and interface adapters, which is this, really these two here. Uncle Bob calls them use cases. When he tends to implement things, it ends up with a lot of different classes. When I do things, it tends to be just methods. So the names for things can get a little bit fungible. But what's in the core module? It's, in essence, the story of your application and its domain. We'll get to that word domain in a second. Domain models, business logic, and interfaces to external interfaces for the system. And those interfaces are things that do side effects. So your core module, hopefully, will be side effect free, which means that you can have near 100% unit testing. It's the story of your application, it's the way that data changes over time, and it will call out to other systems to do anything that actually saves data, prints data, shows it on a screen, does anything like that. And this domain word here, there's a lot of ways to go about figuring out what should be in your domain that are kind of outside the scope of this talk. So instead, I'm going to plug a book. Domain-Driven Design is a book that somehow ends up in every talk that I do. But it's a good book, and if you read this, it will help you figure out what goes in a core model and help you figure out how to model your domain. Over in CatFact's core, it's pretty simple in terms of our domain itself. Let's take a look at that for just a moment. So we've got models, we've got persistence because we need to save it somehow. And we've got a couple things that just kind of live here because I decided to set this up as a multi-platform project that we're just going to ignore for the moment. But the nice thing about Kotlin is the data class attribute. I used to do a lot of Java programming, and in Java programming, we got so many different ways to create these data classes with annotations, doing it by hand, a different set of annotation libraries, all sorts of things. The data class is fantastic, and you can see other languages starting to adopt similar things like this, like Python now has a data class system that's in RFP at the moment. So these are probably one of the most powerful features of Kotlin, which is also interesting because it's one of the most concise. This is a file right here that has a single class with 4 lines in it. Let me get this text a little bigger. And sorry, consume. Thank you. All right, there we go. So we've got a cat fact, which by itself just has an ID, some content, and somebody who wrote it. We've got an account on our system, which doesn't have a password because I didn't do authentication for this because that is hard. And that's pretty much the system. And then we've got repositories. We've got a CatFact repository and a CatFact account repository, which if you go and read Domain-Driven Design, you will recognize these as repository interfaces for aggregate roots of the domain model, which is a fancy way of saying it's a way to get CatFacts. So this is great. It's pretty small. What do we do with it? Well, what we really want to do is expose it via web API. So let's explore the API server. It's just a backend server that exposes a RESTful API. So there's lots of different ways to do this. The probably most common one is Spring and Spring Boot, which kind of lives at the top. And then we've got a few other options, Ktor, Spark, Dropwizard, and probably others that I don't even know about. For this project, I chose Dropwizard. Why? Because that's what I know and have used in the past. But if you've done any sort of API development in other languages, Dropwizard is really easy to pick up and a pretty simple system for doing simple API applications. Like if you use Spring Boot and you've got all these XML files and everything, and it just drives you crazy, Dropwizard makes things really declarative. Honestly, it's almost as fast as programming things in JavaScript at this point, if you've used Express. So let's take a look at the API server. It just lives in another module in our thing, and it's probably a little bit bigger. So view presentation. There we go. So we've got an API server that lives here, and we can register different resources with it. And what a resource looks like is just, it has a path that it responds to, and it has an HTTP method that it responds to. And at that point, it might take in a program, it might not, and then it gives back a response. So Also, this is a new feature in one of the newer versions of Kotlin, the when with a value right here, and I love it. So because I tend to really like functional programming, and we've got this single expression function. You're going to find that a lot in code that I write, except when people tell me that I can't do that. So we've got this great API server here, and I'll share this code with you later so that we can actually, so that you can take a look at it yourself. It's, but then we can just run it like this. There it goes. Our catfax API is running. Ta-da. So we've got all this stuff. It's sharing the same code, and we've got an API server now, which is great. But where's all this data coming from, and how do we get it? So the title of the talk was from the database, and we're getting this from the database. So what that looks like is, if you can see here, the API itself doesn't actually know anything about the database. And it actually is capable of using either an in-memory database or a Postgres database. And what that ends up looking like is all the API server knows is that it has a repository and an account repository. We have implementations of that we can choose between to look at, depending on how we want to store that data. An in-memory database is really useful for testing, whereas Postgres is probably what we want to use in reality. So let's take a look at those for just a second. We already saw the interfaces living in core. And when we take a look at them, this is the in-memory one. We've got an object that just stores data in sets. And then we can just do this to add, get all, remove. And there's some shared fixtures that also live in the core module that we can use to just have a set of data that is usable for testing and for demonstration purposes here. And then we can look at the Postgres one, and this one is a little bit more complicated because we've got Postgres happening. But who here has used JDBI before? Java Database Interface? One guy, okay. So it's a really simple one. Sorry?
JDBC.
JDBC. Yes, JDBC.
JDBC, yeah.
Yep. Okay. Okay, they definitely call it DBI. Okay. JDBC implements JDBI. Yeah. So here we've got the Postgres one, and that just uses something called a data access object, which using JDBC, we can go and create this, which takes us and binds us to SQL queries, which are right here. So now we're at the point of SQL, and that's talking to a database. Yay, database. The thing about having the separate Postgres one as well is that we can also have a separate schema and a separate place to manage the schema. So our database changes don't live in our API server, because technically the API shouldn't care about the database or where it gets its data from. It just wants to get access to the data. Keep the database with the database, keep the API stuff with the API stuff. So that's fantastic. We've got nice separation of concerns. Everything kind of lives in its place. And it looks like a really nice apartment where everything has its own bin. So we've got our API server here, which is great, but then we actually need a way to give this to people as well. We want people to use it. So the main way we want people to use it is with an Android app, right? Well, yeah, because I'm an Android programmer, so. So let's actually run an Android app. Ta-da! we can actually look here and see it's making a call here to the web server. If we click on one of these, there we go. It's actually getting it from the server. Yay. Android. If we take a look at this, let's take a look at Gradle for a minute. So the interesting thing to look here is our Android application only depends on the core modules, which provide that ubiquitous language for all the different layers of the application. And it depends on the API client because we have decided that the Android app is going to talk to the API client, to the API through the API client. Why is the API client its own separate thing and not just a class in the Android, especially considering it's only one file due to retrofit? That's the API server. There's the API client. That's the CatFax API. Have people used retrofit for creating APIs before? Yeah, so it's pretty simple. But we keep that in a separate place. So we load our CatFax, fetch all the CatFax, and show them on the list. And when we're showing an individual one, get that CatFax, get the account that belongs to it so that we can show it the author, and post those to the UI. It's a pretty simple application there. But let's say that we wanted to have a separate application and implementation. So let's see. Let's look at a command line application for interacting with CatFax because mobile is today, but text-based interfaces are the future. So development, cat. There we go. App CLI jar. Let's build ourselves a jar, and you all can hang out with me while we build. Hey, that wasn't so bad. CatFax app CLI libs. There we go. Hey, we have a CLI command. Awesome. So it shows us how to help. It can also list things. Hey, listing, nice. And we can also show a single CatFax, just like that, all talking to the same API. And if we actually go and look at that, we end up with something that looks a lot like the Android application. Up here, we've got show CatFact activity and view model. Here we've got show CatFact command. And this right here looks really similar to this right here. This right here looks really similar to this right here, because there's actually not much difference between the command line and an Android application. It's just a different way of displaying data. And when you externalize everything like this, you can really boil it down to what needs to be done in a given layer. So here on the command line, all we need to do is figure out how to print these data models versus in the CatFax in the Android app. All we need to figure out is how to show an individual one, which here we're using Android data binding to shove the different data into a bunch of text views. So it's effectively the same, just changing where it's getting shown. And the cool thing is it's all using the same core modules, which means when something changes here in the core module, we automatically have access to that in the CLI app, in the Android app, in the API server, which means if you are using I've been on multiple projects before where the API server is being built in a different language than the mobile application, and we end up with this miscommunication where between the server and the client, and sometimes things are named a little bit weird, and sometimes properties are missing or added, and there's all this trouble getting the two platforms to talk to each other. When you externalize your language into a single shared module, suddenly everything can talk to each other much more easily, and that speeds up your development. So that's pretty powerful. We've got multiple implementations here, but if we look beyond a little bit, multi-platform and Kotlin native promise to allow that core module itself to break out of the JVM and get access to JavaScript, to iOS, to other things as well. And that's pretty exciting to me. I know that you've talked about that a little bit. And if you're interested in Kotlin native, stick around for Janice's talk in just a couple moments. And another thing too is in a small domain like the sample application here, we've only got a couple data models, but when your application starts getting bigger and bigger and bigger, you might want to bring in another pattern like CQRS or something. And at that point, it becomes even more important for all of your different parts of your application to share the same language. And that's where having that shared core module really comes into play. And it all comes back down to that funny diagram where you've got a core module that just defines everything that your application can do without side effects, and then a bunch of stuff around that that actually takes that core module and exposes it to different ways of interacting with your application. So that's what clean architecture really tries to help us do. And that's all. Thank you. Yeah, let's do questions. Just a second. All right. Here, talking to just a second.
Okay. All right. Now, the structure is wonderful. I love seeing it.
Mm-hmm.
But is there any merit to taking those modules
Mm-hmm.
and making them into libraries so that you can split them out? And if you're a big enterprise, you've got a lot of developers, got the iOS guys, and they can work on the iOS code
Mm-hmm.
that will be generated from the Kotlin base, and the core all by itself, and each team could work on these independently. If they're all trying to work on this one code base, I can see conflicts happening, etc. So I'm wondering if there's any merit to splitting some of those modules out into libraries.
Absolutely. So I think that's a really good question. And it comes down to whether or not you are willing, whether or not your organization wants to commit to the mono repo, or if you want to break it out into different modules. There's advantages to both. There's disadvantages to both. You see large organizations using mono repos all the time. You see large organizations breaking things out into small individual repos. It's an individual question for every different organization. The main advantage of the mono repo is primarily for the developers, because when you have a single repository like this, you know, it's easy to do dependencies, and you don't have to bring in things like build trains and version bumping and all of these different things, because everything's effectively on the same version. When you start getting into libraries like that, then you start having to bring in these different ways of introducing functionality across repositories, just because you have multiple repositories. That said, when you want to externalize code and allow it to third-party vendors, it's definitely something to consider, especially if you want to allow third-party vendors into your code base to work on it. So it's an individual question that has no straight answer.
Good answer.
So a few comments. It's very nice, and just to answer your question, my opinion and my position is, if you have all this code in the same release cycle, keep them together. If they are on a different release cycle, then you have to split them. So this is basically a very simple answer to this question. Then it's more complicated if you want to keep them on the same cycle. As a web server, small web server, as it seems like here, it is a small web server. Again, I just learned the end of October. There is a Micronaut, which is a very nice framework, which support. So it's guys who wrote Grails,
yeah.
And they support also Java and Kotlin in addition to Groovy.
I'd love to
in this Micronauts. Now you said that the service part inside has no side effects, and yet you said that it does have a persistent there.
Yes.
So the persistent basically is a side effect.
The core module externalizes the side effects. So the interface that's defined in the core module can affect a side effect, but there is nothing inside the core module itself that actually causes a side effect, which means that we can test the existence of those side effects simply by
marking the persistent layer.
mocking the the persistent layer, the interface.
Okay, and the last question is everything in Kotlin, and yet Gradle builds still in Groovy. Why wouldn't you use Kotlin DSL for that?
That's a great question. Because I didn't have time to do it.
Okay. Okay. Thank you.
Yeah. Any other questions?
So you mentioned versioning, and I actually had a question of, so you can't really be sure that the client's going to update immediately. How would you manage versioning the API when you have Catfax 2.0 and someone doesn't update their CLI? How would you handle that with something like this?
There's a lot of different ways to do versioning APIs. Like that's an entire talk in and of itself.
Oh, I guess it was more of how do you manage it in your own code base here, other than having just a V2 of everything?
Yeah. So I mean, this is a simple example code base, so it doesn't actually deal with versioning. But there's a lot of different ways to deal with API versioning. We can talk about that more afterwards.
Cool.
Yeah. That's a complex question.
Sure.
Yeah. Anybody else?
So when are you building the iOS version of this?
You're going to have to talk to my colleague Matthias about the iOS version. Cool. All right. Thank you.